I'm sorry. Okay, here we go. I'll go to read them out loud. Okay. Oh, sorry. Um, which of the following variables is slash are quantitative? Mark all that apply.
Just
So,
the last one. I think it's the first and the third.
I think that it's the first two.
Why is it the first?
I don't know.
You can't divide that by 2. The test to see if something's quantitative is to divide it by 2 and see if it still makes sense. You
Okay,
can't
so
divide
I thought that it was qualitative, the question. So that's why I put that. So now I'm only putting the last one.
Okay.
you ready for the next one?
Mm.
Students in an introductory statistics class at BYU, Idaho, are studying prices of cold cereal at grocery stores in Rexburg. To get a sample of a cold cereal prices, they went to Albertsons and rolled a die to decide which box from the left of the top shelf they would start on. Then they recorded every 6 cereal after the first, moving left to right down the shelves, recording the name, size, and price of the cereal.
Bye, Tessa. Love you too. Have a good day.
Is this an experiment or an observation?
Bye.
What do you guys think?
Oh, I don't know. I'm doing a different problem. I'm trying to figure it out because it's just taking me forever.
It's been a while since I've done this. Let me see.
Okay, I don't know. I'm tired.
I don't know either. I mean, I know this is a definition. In an observational study, investigators observe subjects and measure variables of interest without assigning treatments to subjects. But I don't really know. I don't know. I guess just guess.
I put that it was an observational study.
I thought it was observational too.
I mean, how are they doing an experiment, guys? It's obvious. They're not.
Riley, don't be mean. You're not.
No, I'm not being mean. I'm just saying, like, think about it logically. They only have one variable. You can't do an experiment with one thing. But they're not comparing to anything. Okay. That's 9.
Okay. Let's see. I'll read 4. For a Math 221 project, one group of students studied the ages of students on the BYU Idaho campus. They collected data from a random sample of n equals 100 students. The sample mean was 21.2 and the sample standard deviation was 2.61. An expert of their data is given below. The group notices an error in the data, error in their data.
What was that? An error?
I don't know.
What was that?
The age of one of the males, ID equals 3, was entered incorrectly. He's actually 21 years old. When the error is corrected, what will happen to the sample median? Oh boy, it's gonna run.
I would say it's not possible to
to determine without the full set of data.
I just put that I thought it wouldn't change. I don't know if that's right or not. That's what I put.
Well, because the median is the middle number.
Right, so why would it matter if the beginning number changed?
Because the 12 would actually be changed to 21, which means that the count would be different.
Right.
order.
Would it really, though? Because they would
Yes.
still just start at the smallest number and go all the way to the middle.
Right, but 12 was originally, like, probably the smallest number.
I see what you're saying.
So I think it would increase.
That wasn't you, Siri. Okay. I'll go with that. That seems logical to me.
Okay. The time to complete a standardized exam in the BYU Idaho Testing Center is approximately normal, with a mean of 70 minutes is a standard deviation of 10 minutes. Using the 69, 95, 99, 7 rule, approximately what percentage of students will complete this exam in under 50 minutes? One second. I need to go.
Isn't it just 0.3?
I have 2.5. But I don't know that that was right because I didn't feel like looking it up in my notes. I just did
For
what I thought.
question
Well,
5,
because it's within 2 standard deviations.
But they're not asking you that. They want to know who completed it in under 50 minutes.
Oh, okay.
So, I don't know. You guys should go about it and see if you get a different answer. Because I just did something random I thought would work.
I'll be right back. I forgot my calculator downstairs. You guys can go ahead, though. I'll be back.
Hello.
Hi. Really just
What stupid pen is. Maybe that's okay.
what did you put, Riley?
It's 2.5.
How did you get that?
I just added the last, so like 2 standard deviations is 95%. I divided in half what was left over, which is actually makes it, I don't remember. So I divided in half what was left over and I added it to that, and then I subtracted 95. Something like that. I don't know what I was thinking, but that's what I did.
Yeah, that makes sense. I was doing it. I guess I was just getting confused because I was using the 99.7.
Which was 3 standard deviations.
Yeah.
Yeah. So, like, there's 5 left over from the
Just go with
99.5 rule, and then you can divide that in half to see what's on both sides, and then, like, just one side of that would be under
Yeah.
50, I think. I don't know. I don't feel like thinking about these too much because I'm tired, so I was like, hey, first answer, that works.
Makes sense. Yeah.
On number 6, I'm just trying to figure out, also, why am I hearing myself, Maddie?
Because your door is open.
It's freaking me out. But anyways, with the next one, I was just trying to remember, I don't think that if we're dealing with a population, that we have to have n for that equation. So I was just trying to figure out how to do the equation without n, because I thought we had always had one in the past. So that's just what I've been doing.
For this, you have to type in 0.35 into the normal probability applet to find the z-score. And then you set that equal to the mean minus the value divided by the standard deviation.
Okay.
I mean the value minus the mean.
It's the standard deviation divided by the square root of n. But I guess you're right, when it's the population, it's not that way.
So I got 146.8.
I got 141.163.
Okay, wait. How do you get it in the probability applet, Sarah?
You just type it into the area, so type 0.35.
To the top?
Yeah.
Okay. And then which parts do you want selected?
It doesn't matter. You're taking the z-score.
Okay.
Wait, what are they asking us? The
So
35th
the z-score I got is negative 0.385.
That's not what I got.
No, the z-score is negative 0.935.
Yeah, I
That's what
got
I got.
I don't know what happened with.
Oh, okay. Yeah, I guess I must have typed it in wrong.
Yeah, I don't know. Let me see something. I'm multiplying the skin to double check my problem. Where's the standard deviation? Where is it? Okay. 10.2. Minus. Well, now I got a different number.
What did you get, Riley?
Hang on, I'm getting a different number doing it this way. I'm trying to think about this logically in my mind. Okay. So I think it's 160. Now I got 160.237. Maybe I should actually write this down so I'm not doing anything. What did you guys say?
I just got 141.163.
Yeah, so I used the negative z-score this time
That's what
because I had a realization that that's the one we're supposed to use. And so then I multiply that by the standard deviation, which is 10.2. And I got negative 9.35337. Gosh. And then I subtract 150.7 from that.
You should be adding that though.
But 150.7 in the equation is supposed to be subtracted. You're subtracting 157 from it. And I'm not using 157, I'm just using 150.7. So since it's positive, I'm pretty sure I have to subtract it.
So in my equation, I put x minus 150.7 because it's the value minus the mean.
Is it the value minus the mean? I thought it was the mean minus the value.
It's value minus the mean.
Okay, then you're right. That's the number I got originally anyway, which is funny. Yeah, that's the number I had before. So it is 141.160. Thank you, Sarah, for your knowledge. Okay.
Maddie, are you reading it?
Well, I don't quite understand what. Are you
the last
or what? Are we ready to move on, or what's going on?
Do you understand how we got question 6?
Oh, not really. I don't really understand what equation you guys used.
We just use the z-score equation, Maddie, like before. We just plugged in what we got from the applet for the z-score as a z-score and then just did algebra to solve for x.
Oh, okay, so what did you guys get?
141.163.
So did you do 157 minus 150.7 divided by 10.2? Because that's what I did.
No, 157.
No, you're not solving for the z-score. You don't use 157 at all.
Okay.
Because that's
You're
just
doing algebra.
unnecessary information.
Okay. I still don't understand what you guys did.
I just told you that you plug in what you get in the applet for the z-score in the equation and then solve for x. So you're going to have like whatever the numbers you got from the applet equals x minus 150 point whatever the mean was. And then that's going to be over the standard deviation, but you have to use algebra. You're not solving the equation. So you're going to have to like do the same thing to both sides, which would first be multiplying the standard deviation, and then you would add your leftover number from the top to the other side so that you're left with only what x is. Like it'll be an equation. So you'll have like something on the left side and it'll be equals x. And that's the answer if you solve it on your
Do it
paper.
on my own because I'm slow with math and that's gonna take me a while. I'm sorry. Last time, what did you guys get for it? We could just move on. 141 point what?
163.
Oh, 163. It's 163.
Yeah.
No, we're rounding to one decimal place, so it would be 141.2.
Okay, 141.2.
It's weird that they had us do that for that question.
Okay, I'll just have to go back and try that on my own. Okay, 141.2. Okay, a team of dermatological researchers were studying skin cancer among 60 to 70-year-old American men. Suppose you were a part of the research team and take a sample of men from this age group and calculate the mean number of skin cancer spots in the sample. Also suppose that it is known that the distribution of the number of cancer spots is right skewed. Suppose the sample size for the study is n equals 2. What will the shape be for the sample?
I would say skewed, right?
Yeah, I'd say that there. Okay, if we're all good with that. Tanker trucks are designed to carry huge quantities of gasoline from refiners to filling stations. The factory that manufactures the tank of the trucks claims to manufacture trucks with a capacity of 8,550 gallons of gasoline. The actual capacity of tanks is normally distributed with mean U equals 8,544. Sorry, that was a weird way to read that. Sorry, 8 gallons and standard deviation equals 12 gallons. Suppose that the simple random sample of n equals 20 is selected and sample mean capacity is found to be 8,550 gallons. What is the z-score corresponding to the sample mean? So are we just using a normal?
Yeah, just the normal z-score equation.
Okay. So let's see.
So I got 2.236.
Me too, yay.
Yep.
So it's so it would be the 8,544 minus the 8,550, right?
Nope, the other way around.
The other way around. Couldn't remember the order.
Well, isn't it?
Because you had just told me last time it was x minus the mean, Sarah.
Yeah. So, the 8544, that's the sample, so it goes first, right?
No, 8544 is the mean.
I know, but we're given two means.
I know, but in the question, it says that your sample is 8550. I don't know, whatever you did, we both got the same answer.
That's
Yeah,
what I got too.
I tried it both ways, actually.
And you got the same answer both times?
Yeah. Well, it was approximated, but yeah.
Yeah, okay, so it doesn't matter anyway then.
Well, but for the test, we need to know.
Well, I'm pretty sure, let's see. The actual capacity, 8544, is the mean. That's the population mean. That's what matters. We're only looking at the mean in the sample as x because that doesn't represent the population, and we're comparing it. The mean of the sample in question 8 under the question 18 is 8550. So that's why you do it that way. Oh, that was stupid. I was just doing something stupid. I was doing the next problem and I accidentally typed in the same numbers again. Okay.
What did you guys get?
2.236.
I guess we'll just move on.
Bye.
Did we all get that same number?
Yep. You weren't listening when Sarah and I talked about it, I guess.
No, I was trying to figure it out on my own. Okay. What is the probability that the sample mean capacity of 50 random selected pigs will be greater than 8,540 gallons? I don't know how to solve that one.
You missed the last problem. They're just new numbers.
So for this, aren't we just typing in the z-score into the normal probability output?
Oh, yes, we are.
Yeah, because we have to, because it says greater than, so we need to do it to the right.
Oh, that was stupid. Okay. Oh, that worked.
So I got 0.9873.
9873, really? I got 0.991.
I got the same as Sarah.
I don't know what I did. What did you guys use for the mean?
I just, let's see.
Hold on, I'm doing it again.
Because the mean should still be 8544.
That's
The standard deviation is still 12.
What did you get, Riley?
Rounded 0.991.
I got really close to that this time.
I don't understand what you guys are doing because I'm getting a completely different number.
It's just the z-square equation.
So it's x minus u divided by the sample, right?
No, divided by the standard deviation divided by the square root of it. Because we're doing samples, not populations, so you have to have that other part.
So it would be 8,540 minus 8,544 divided by
Divided by 12 divided by the square root of it. And also, people, I have to bounce because it's 8:30, and if I don't start baking now, I'm going to be baking forever. So, I love you all, and I shall see you later. Good luck.
Bye, Riley.
What are we saying it is then?
I don't know. Sarah, were you gonna try and do that again, or?
So I have it typed into the normal probability applet, but I guess I'm confused about what part we're highlighting.
Well, I think since it's greater than, you would highlight to the right.
So when I do that, I get 0.4813. Is that what you guys are getting?
No, I don't know, because I'm not even getting the right. I mean, when I plug in 800,540 minus the whole equation plugged in, I get a huge number, which I'm sure you guys aren't getting. I don't know what I'm doing wrong. I'm really confused.
What was the z-score you got, Sarah?
Negative 0.4047.
Okay, that's not what I got.
Okay. I'll try it again.
Okay, now I got negative 2.357.
For your z-score?
Yeah.
I don't know how you got that.
I did 8,540 minus 8,544
Those
divided
are the
by.
real numbers. It's 8,550.
It's 8,540.
Yeah.
No, it's 8,550 minus 8,544.
Yeah, it is. You're right. I don't have my glasses on, so I didn't really see it.
So I'm looking at the problem right now, and it says that the sample mean we're looking at is 8540.
Not for the.
Oh, you're right. Okay, then I got negative 2.357 for the z-score.
I did too. And then I got 0.991 for the answer.
Yeah.
So.
So I'm getting negative 1.491 for the
I don't know what you're doing, Sarah. Are you highlighting to the right?
Well, no, I mean for the z-score itself, I'm getting negative 1.491.
Yeah, I don't know what you're doing because I'm not getting that.
Me neither.
When you guys are typing it in, are you putting 12 divided by the square root of 20 in parentheses?
No.
12 divided by the square root of 50.
Yeah,
Oh, okay.
because it's the sample mean capacity of 50 randomly selected tanks. Man, we are all having a problem. It's funny how we both switched in reading the. I'm gonna get my glasses on.
So now I'm getting negative 0.04.
Yeah, I don't know, Sarah, because we both got the same thing, and that's the same number that Riley had got too.
Yeah.
I literally have to run downstairs because I just have 2% on my. I'm really hoping it doesn't die.
Okay, so this time I got negative 3.536. Isn't the z-score you guys are getting?
No, I got negative 2.357.
Okay.
I don't know. But I don't. We better not spend too much.
Let's just move on.
Yeah. Sarah, is that okay if we move on?
Okay, so what's the answer you guys are getting then?
0.991.
Okay.
I I was dumb and I accidentally deleted the answer for 8 because I was getting confused at what we were doing. Can someone just give me that answer really fast and then I'll read the next question?
Yeah, it's 2.2.
2.236.
2.236?
Yeah.
All right. So, number 10, which one of the following best describes the notion of the significance level of a hypothesis test?
I believe it's the probability of a type 1 error.
I think you're right.
Annie, what do you think?
I think it's the probability of rejecting HO, whether it's true or not.
Hmm. I don't know. I guess we could just have one person do one and one do the other. I don't know. Riley thinks that Sarah's right.
Okay, we can just go with that.
I don't know. Okay. Question 11. The heights of young adults females in the United States are said to have a population standard deviation of 2.6 inches. A sample was taken of n equals 85 young adult females at BYU, Idaho, and the mean was computed to be 65.4 inches. Which of the following explanation describes the correct way to interpret the 95% interval for this problem? So do we need to solve it, or doesn't it
No.
do? Okay.
I think we are 95% confident that the true mean height of adult females in the United States is somewhere in our confidence interval.
It says mark all but apply. That's confusing. Okay. So we can do more than that.
So I think we could also check the first one as well.
Yeah.
Yeah, that makes sense. And just leave it at that.
Yeah.
Okay, let's move on then. I'm gonna unfortunately have to leave too soon, which I don't know how that's.
I'll probably just leave too when you leave, Maddie, and finish the rest on my own. Because honestly, I really just want to sleep right now.
Okay. Okay, question 12. Marine biologists have been studying the effects of acidification of the oceans on weights of male beluga whales in the Arctic Ocean. One of the studies involves a random sample of 16 beluga whales. Researchers want to create a 95% confidence interval to estimate the true mean weight of male beluga whales. Their data follows a normal distribution. The population standard deviation of weights of male beluga whales is 125 standard deviation, and the researchers feel comfortable using the standard deviation for their confidence interval. A requirements met for the use of a confidence interval. Explain. I don't think it really matters about the distribution, it matters about the sample size.
Well, if it's the sample size that we're focusing on, then that we don't have enough
Yeah.
to it. But also they used a QQ plot and they got that their distribution of sample means is normal. I mean, sorry, that their data is normal.
Yeah. I don't know, that's hard, because Okay. Maybe I'll just go with B then.
Well, Annie, what do you think it is?
I think it's B.
Alright, we probably maybe have time for one or two more problems, because I gotta leave at 8:45. The next one's... Okay, we'll just see what we... I kind of almost want to skip the 13, because that's wrong, but... Can we just read number 14, since I have to leave in 2 minutes?
Yeah.
Okay.
That's fine.
A financial economist is studying married couples in which both spouses work. He wants to compare the mean income earned by husbands with the mean income earned by their wives. Should he use independent sampling or dependent sampling, and why?
Dependent sampling.
Yeah, because they're together, I agree.
Yeah.
So, would it be B then?
Yeah.
Okay. I guess I can see what the next one looks like if we have enough time. Probably not. Okay. I'm sorry that we weren't able to get it all done. I mean, if you have any questions, Sarah, we can always go through, or if we have questions and we're struggling about solving something, we can always go through them all, or if necessary, for anyone that wants to, we can come back on a video chat.
Okay.
If, like, just let us know if that's what you need. I might need that just because I struggle with math, but I'm sorry for cutting it short, but good luck. Everyone just send an email if you have questions, and we'll try and figure it out that way or through video.
Yeah.
Bye, guys.
Bye.